Just a little side note here. We've got a circle, and I've got a segment in orange whose length is the diameter of the circle. And we want to try to construct a segment of length equal to the circumference. Can we do it? Well, if we could, then you'd make a liar out of me. You would have constructed factor pi, and I said it can't be done. Okay? At least not with a finite number of operations. Well, let's see what we could do to at least get close to pi. Okay, so first thing I'm going to do is I'm going to construct the perpendicular bisector of this diameter, and then I'm going to take this length, this length, this length, and this length, and I'm going to add them together. Let's see, this compass won't quite stretch out that far, but I take this length and this length and this length and this length with my compass, and I can okay, well, let's just do it. You know, that length is there, so it's about here, and here, and here, and here. Okay, so from here to here, is that it? Well, no, that's a little short. Okay, if whatever the diameter is, it turns out that this length is 2 times the square root of 2 times the diameter. Okay, well, square root of 2 is about 1.414, double that, 2.828 times the diameter, and we know pi is 3.14159, Okay, so we're somewhat short. We're around 2.8, where pi is around 3.1. So we're off by about 0.3. So we're off by about 10%. So we didn't do a great job, but you know, we aren't that far away. We're within 90% of. We got 90% of it. Well, next thing I can do is I can bisect a right angle. I can bisect any angle, cut any angle in half with a geometric construction, very similar in some ways to the one we used to bisect a line segment. As a matter of fact, I could bisect this green line segment here and then just draw a line from the center through that bisector and extend back here. It would work back this way too. And I'd do the same with either this segment or this segment, the green segment, and I would have my bisector. Okay, and now I've got 8 of these segments. So something's coming loose here. Okay. I think that can be tightened down. Okay. So I can now, you know, I can use my compass. I can get the length of this segment, so I can mark off that length here, and then I can do that 8 more times, or 7 more times, to get a total of 8. So maybe I have room to do that here. Depends on how accurately I did what I did before. Let's see if we can fit it onto the board. Okay, so got this distance. If this is constructed accurately, now I drew this freehand. Some of these segments are longer than others, some are shorter, so I don't know how this is going to work out. But if I've got a marker on the end of this compass, I can mark here, and I've got the segment, I can mark here, and then I can continue marking 8 of them. But if I've got a long enough compass, of course I can just do this and double this length, which would get me the equivalent of 4 of these. Then I just double this one, and I'm out here. Okay, and now the distance from here to here is going to be a better approximation of pi. Okay, now can you geometrically, using Pythagorean theorem or whatever, can you determine the lengths of these segments in terms of the diameter and get a number that corresponds to this distance. Might be possible to do that. Well, we can continue this process as long as we wish. We can bisect each of these angles, and now we have 16 segments, and now those segments are going to be pretty darn close to the circle, and we ought to be getting pretty close to the accepted value of pi. Of course, we can continue this. We can continue this for 20 steps. And at 20 steps, we're going to have over 1 million segments. So it's going to take a while to construct it, but maybe we can write out the mathematical expression for the length of those segments and evaluate it and determine better and better approximations to pi. Now, so what we've done is we've constructed an approximation to the circumference, the length of the circumference, a line whose length is close to the circumference. This line is much closer to the length of the circumference. And if we continue this process, we will approach the length of the circumference. We will approach that length as a limit, and that's terminology that is going to become very familiar to you as you move into some of the higher mathematics courses that are probably in your future.